Welcome to Mastering Solutions. In this motion in 2 dimensions problem, they ask us to complete this motion diagram by adding the acceleration vectors and then to write some sort of physics problem that would correspond to the diagram. Whenever we are going to add acceleration vectors graphically, what we're going to do is we're going to be subtracting vectors, and that's because if you remember, the acceleration formula is equal to the change in the velocity over a change in time. Obviously, change is equal to v final minus v initial over t final minus t initial. We don't have any time, so obviously we're just looking at the change in the velocity, and it's assumed that there's a time difference between these because each of these are taken at a different snapshot. If we look at each dot, we can see that the first half of the problem right here, they're all going the exact same distance apart. So right here, acceleration is equal to 0 because it's going at a constant speed, so there's no change in the velocity. Right here, it's going in a downward motion. I'm thinking of this, my problem will be something like a ball rolling off a table or something like that. So if we're looking at the side, you can see right here is where it falls off the table, and then this is gravity pulling it down. So what we'll do is we'll take the difference between these two vectors. So this point right here is where we're going to get the acceleration at that point. This is the representation of the initial velocity for this point, and then this is a representation for the final velocity at this point. So when we subtract vectors, we take the one that we're subtracting by, in this case is the initial velocity, and we turn it backwards. And then we'll slide it down here and try to draw exactly the same as it is above. That's pretty good. And then when we draw the resultant vector, we're drawing from the tail of this one down right here. So we'll do the same thing for this one. So we're going to take this initial velocity for this dot now, and we're going to turn it backwards. And then we'll slide it down to this one. We'll try to draw it the exact same as it is above. Looks pretty close right there. And now when we draw the resultant vector between these two, here is the acceleration. So for this one, if we think about it with the example that I said, where a ball rolls off of the table 1 meter from the floor, so we have the table right here, and then this height is 1 meter, and then the problem could be like draw the acceleration vectors for the motion diagram. And so for this situation that we talked about, acceleration in this case is pointed straight down, so acceleration is negative g for my problem. You can come up with your own problem for this, but here is the acceleration vectors, which are represented by the blue arrows. And then my problem, as I talked about, is a ball rolling off the table and then falling down to the floor.